Hello, this is Dr. Gonzalez, and in this video, I'm going to talk about hypothesis development. If you're in Psych 4371, in Canvas, there will be two separate sets of notes and corresponding video concerning hypotheses. There will be this one about hypothesis development, and then there will be another video that talks about hypothesis testing. They're related, but there are separate things that I need to address in these two particular videos that I wanted to make sure were kept kind of separate. So I apologize if you're hearing any additional sounds with this video. It is pouring down rain outside. I mean, it came a massive, what we would call in Mississippi, a gully washer. So without further ado, let's talk about how we develop our hypotheses. So what is a hypothesis? A hypothesis is just a testable statement about a relationship between two or more variables. Now, a lot of this particular presentation is built off of the non-experimental concepts that I use in Psych 4370. So you'll see references in here to correlational research, but this is no different when it comes to an experiment. In an experiment, a hypothesis is still going to be a testable statement, and it is talking about the relationship between two or more variables. In an experiment, though, that relationship is assumed to be causal, okay? In correlational research, we're just looking at whether or not there's a relationship between those two variables. In an experiment, we're looking to see if one variable is actually causing another. So this video is going to help you craft your null and your alternative hypotheses so that when you get to your research paper, you'll know what you're doing. And it also says we're focusing on correlational claims. Everything in this video is from a correlational perspective, but I'm going to help you see how you can easily change that for your experiment. So a null hypothesis is going to state that there is going to be no relationship between the two variables. So what you're observing in that relationship is actually just due to chance rather than an actual association or a causal relationship. So if we think about it from an experimental perspective, I'm looking to see if variable X causes variable Y. Okay, my null hypothesis is going to tell me that variable X does not cause variable Y. The characteristics of a null hypothesis: first, it assumes that there's no relationship. Whether that relationship is correlational or causal, it doesn't matter. The same thing is true for a null hypothesis, whether it's an experimental or non-experimental setting. So what that null hypothesis is your default assumption, because as you watch the video on hypothesis testing, you will see that in hypothesis testing situations, we assume that there's no relationship. That's our default assumption. You're not trying to prove a relationship exists. You're trying to prove that there is no relationship. And I know that sounds kind of silly, but it's how hypothesis testing works. So in our hypothesis testing situation, you as the researcher, you're attempting to reject the null, and you're supporting that with data. So if the null hypothesis is not rejected, there's no relationship there. You're retaining that null and saying that that null is actually true. Now, in correlational research here, I have a research question. What's the relationship between the number of hours of sleep per night and daytime sleepiness among teachers? I want to write that in a null. I'm going to say there's no significant correlation between the number of hours of sleep per night and daytime sleepiness among teachers. There's just no relationship there. So that means that if I see any sort of relationship, it's purely coincidental and it's not meaningful. Now, how would we write that in an experimental situation? So let's go through here and talk about that. So in an experiment, we want to see if there's a causal relationship, right? So we want to know, does variable X cause variable Y? So what is that null going to look like? It's going to look like this. Let's assume that we are testing a new medication for insomnia, and we're going to call it, I don't know, I'm going to give it a funny name here, but let's call it Sleepy Med, okay? It took me a minute, but does taking the medication Sleepy Med cause participants to sleep longer, or to cause participants to have better sleep quality? There you go. So I have variable X and variable Y. Variable X would be my Sleepy Med, right? And I'm looking to see if it's causing a change in variable Y, and that change would be better sleep quality. So how would I craft my null here? I would say there is no significant difference between the quality of, there's no significant difference between so there's no significant difference in participants taking Sleepy Med with regard to sleep quality. Let's put and duration. So what's going on here? They are sleeping. Switch that around for you. Let me fix that over there so I don't accidentally turn it off. So in an experiment, I'm looking for a causal relationship. Is variable X causing variable Y? In this particular example, I want to know if taking Sleepy Med makes my participants sleep better and have a longer duration of sleep. Do they sleep longer? So my null is going to say there's no significant difference in participants taking Sleepy Med with regard to sleep quality and duration. So I'm obviously comparing them to another group, my control group, that is not going to receive Sleepy Med. Okay. So what is your alternative? We usually write it with H sub 1 or H sub A. A stands for alternative, and that states that there is a statistically significant difference between the two variables. So in a correlational situation, it's going to predict the change in one variable as being associated with changes in another. So let's look at what that would look like. So it suggests that there's a relationship or a correlation. It could be positive or negative if it's a correlation. It gives me my support to my alternative, and it's going to be associated with a statistical test and a significance level. Usually we use the p-value of 0.05. And when our p-value is less than 0.05, it means I'm going to reject that null because the alternative has been proven correct. So here's an example in a correlational study with a non-directional alternative. So this predicts that there's a relationship, but it doesn't tell me where, and that's two-tailed. So it could be either a positive or a negative. And the example I have here is that there's no significant correlation, and I'm not specifying whether that correlation is positive or negative. Okay, so there's just a correlation. Now, in a directional alternative hypothesis, you're going to postulate that it's either a positive or a negative relationship. In a negative correlation, you have a significant negative correlation between the number of hours of sleep per night and daytime sleepiness. So in other words, as the number of hours that you sleep increases, your sleepiness during the day decreases. Makes sense, right? If you sleep more at night, you're going to be less sleepy during the day. And then your second one is a positive correlation, and that's when both of them move in the same direction. So that means there's a significant positive correlation between the sleep duration and the daytime sleepiness. So the more you sleep, your alertness increases. Now let's look at what a let's look at what an alternative would look like in an experimental situation. So I'm going to put that slide right there. And I just messed that up. I don't want to do that. I want to copy this one. And I want to put it right here. So let's go back and look at sleepy med. We're looking at, does variable X cause changes in variable Y? That's our basic question. Go back up here and look at my sleepy med example. My question I was looking at was, does taking sleepy med cause participants to have better sleep quality and duration? So my alternative hypothesis, I have an example here somewhere. Where did it go? Oh, I'm just going to have to write it. So we write it as H, and then you need to go and find your subscript, and you can write an A, and then turn your subscript back off. So my alternative would be that sleepy med causes participants causes a significant difference in sleep quality and duration. So in other words, when you take sleepy med, you are more likely to sleep longer and better than if you did not take sleepy med. Okay? So that's just a breakdown of the two situations. One's a correlational example we just went through, and you watched me edit and add slides in for an alternative and a null hypothesis in an experimental situation. So what's the purpose of all of this? So hypothesis testing ensures scientific rigor. So it helps us as scientists remain objective because we're stating our hypotheses beforehand. We cannot change them on the fly. We talk about moving goalposts a lot of times with politics, especially. So politicians will come out and they will say, here is the point of my new endeavor. It's to do this, to decrease, I don't know, reliance on food stamps by 20%. And they get into their term and they realize they can't meet that goal, so they start moving the goalpost. Well, we don't want to do that in research. We want to be objective from the beginning all the way through. So by clearly stating our hypotheses at the beginning, we're going to actually tell everybody what we're studying. There are some people out there, there's a push to have researchers publish their hypotheses before they even conduct their studies. Not just that they create them, which we all do that, we create them beforehand, but to actually publish them and to register them. And that is an added layer of accountability that they're trying to add to research. You're going to talk later in the course about p-hacking, and p-hacking is basically when a researcher sets a p-level, a significance level at the beginning of their research, but along the way, they start changing it. And they do that for a variety of reasons, but one reason is for them to actually try to capture some relationship that does exist out there. So the second reason why hypotheses are important is they help us prevent false assumptions. So let's go through a few examples that are specifically tailored that there is no relationship, whether it be correlational or causal. I realized that the video that I made, that there's no relationship primarily on correlational research. So by starting from that negative point, we are not building off of a false positive within the experimental context. Now, so my first example is about sleep and screen time, and it's based off the research question through that data analysis. Does limiting screen time determine 1 hour before bedtime improve sleep quality and duration in college students compared with no screen use restrictions? Every time it opens up a treatment and a control group, right? So my null hypothesis is
Now,
going to simply state
in the next part
that
of
there
this
is
video,
no
I'm going to
difference
walk
in
you
sleep
through
quality and duration.
several examples.
My alternative hypothesis
of
is going to state that there is a significant difference in sleep quality and duration.
experimental research questions.
So your null and alternative hypothesis can be as simple as these two statements right here, or they can be more complicated, as you'll see in some of these other examples. So in other words, what I'm saying in these two hypotheses here is that students who restrict their use of screens right before they go to bed are going to sleep better and they're going to sleep longer. And when we reject the null, we've got the statistics to back that up. The next example is depression and therapy type. So we're going to compare in this research question two types of therapy for mild to moderate depression. So we want to know, does CBT reduce depressive symptoms better than supportive counseling, SC, in adults with mild to moderate depression? So my null is that there's no improvement in depression symptoms based on type of therapy. And the second one is my alternative, and it states that there is significant improvement in depression symptoms based on the type of therapy. So this is a one-tailed example because I'm looking at specifically at improvement, right? So in other words, CBT works better than the standard therapy, and I've got the stats to prove it. My third example is about dyslexia. So my research question might say something like this: does a multisensory, phonics-based reading intervention improve reading fluency in elementary students with dyslexia when compared to standard reading instruction? So my null is going to say that there is no difference in reading fluency, and my alternative is going to say that there is a difference in reading fluency. So in other words, reading fluency is going to be better if they participated in the multisensory phonics-based intervention as opposed to the regular instruction. Example number 4 is about social media and attention. So my question we're asking is, does taking a 1-week break from social media improve sustained attention in college students compared with continued social media use? My null says there's no difference, and my alternative says taking a 1-week break will help improve and provide better sustained attention when compared to students who don't. So this is another way of wording it that's just slightly different from the other examples. But in other words, the bottom line is taking a 1-week break from social media is going to improve your sustained attention. And the last example, I had to do one kind of silly because I have a cat and I am convinced that I don't sleep as well at certain times due to the cat being there, mainly because she likes to kind of get in my face and paw at me when I don't get up to feed her as quickly as I should. But my question would be, does sleeping in the same bed with a cat improve sleep quality and duration in adults? So my null is going to say there's no difference in sleep quality and duration when sleeping with a cat or not. And then your alternative is that there is a significance in sleep quality and duration when you sleep with a cat. So it could go either way. We're going to pretend this is a one tail, and we're going to say that there is a difference and it happens to be worse. So there's your one tail there. So those were just a few examples of some other research questions and their associated hypotheses from an experimental point of view. Make sure you go in and watch the video about hypothesis testing. It is building off of these concepts here, but you should have enough information now to successfully write your null and alternative hypotheses for your assignment.